El Nino is ramping up and heating the Pacific. The Atlantic is already overheated. Why Dr. Phil Klotzbach is not impressed with El Nino, and what this means for the hurricane seasonal forecast. This is NTWC Live.
Good morning, everybody. Welcome to NTWC Live for Wednesday, August the 9th, 2023. Glad to have you along today. Great program lined up for you today. Dr. Phil Klotzbach is back with us. We're going to get an update on the hurricane seasonal forecast. We'll find out whether he thinks El Nino or the record-setting Atlantic sea surface temperature is going to win out as we head into the hurricane season. I want to thank our sponsors who are here again this year for NTWC Live. USAA, South Padre Island Convention and Visitors Bureau, the Weather Company, and Weather Boy all make these broadcasts a possibility each and every week. So we appreciate what you guys do to make this a reality. Coming up just a little bit, Dr. Hal Needham is going to jump in the conversation, the disaster scientist, extreme weather disaster scientist with CNC Catastrophe and National Claims. But first, let's get to Bill Reed, former director of the National Hurricane Center. Bill, one day early. Happy pre-birthday.
Well, back at you, Tim. Everybody, it's Tim's birthday today. He's 10 years younger than me, and that's as far as we're going to go on the numbers game.
We'll leave it at
that. Yeah. Well, we're ratcheting up a drought to go along with the heat. We had a fairly wet spring across much of Texas, but a lot of that's being erased by the extensive heat wave we've had for the last 6 weeks or so. And there are people telling me they wish we'd get a tropical system to break it, and I keep telling them, be careful what you wish for. Our guest today is Dr. Phil Klotzbach. He's out of Colorado State, told us it was down to 38 degrees there. Eat your heart out, fellas. And always love to have Tim on this show. He got his PhD working on the inimitable Dr. Gray, and much to our joy, he's followed in Dr. Gray's footsteps to keep their work going on the seasonal forecasts. And we've got something new every year, and I always like to bring him back every possibility to tell us what's going on. So welcome, Phil.
Well, thanks so much, Bill, and thanks so much to all of you for tuning in. Let's see, my screen share is loading. Participants can see my thing. Not now. Let's do this. All right. Let's talk about the hurricane season. You know, it's been an interesting one. And, I think this hurricane season itself is kind of presenting us with something we have not seen in the recent historical record. And that is, as Bill noted, an extremely warm tropical Atlantic, and also a robust El Nino at the same time. And so the question is, it's kind of the battle of the Titans. Which one is going to win out? And maybe it's a draw. Maybe it'll just end up being a dead-on average season. So I think there's a lot of uncertainty associated with this outlook. And if you read outlooks from our group, from NOAA, from other groups too, there's just a lot of people keep emphasizing just how uncertain this year is. But I did want to spend some time kind of talking about what we've seen so far and what our outlook is for the remainder of the 2023 season. So here's our last forecast that we put out just a few days ago. We did maintain our numbers from what we put out in early July. We're calling for an above normal hurricane season. An average season has 14 storms. We're predicting 18. An average season has 7 hurricanes. We're predicting 9. An average season has 3 major hurricanes. We're predicting 4. Major hurricanes are category 3, 4, and 5 hurricanes. On the Saffir-Simpson hurricane wind scale, winds of 111 miles per hour or greater. We're also forecasting above normal levels of accumulated cyclone energy. That's an integrated metric accounting for storm frequency, intensity, and duration. I should note that these numbers do include the storms that have already formed. We had a subtropical storm that formed in January, as well as Arlene, Brett, Cindy, and Dawn. So we're forecasting an additional 13 storms and an additional 8 hurricanes since Dawn last month did reach hurricane strength. To give you an idea of how our forecasts have trended, we have actually increased the numbers from April, where we forecast a slightly below normal season, to June, where we forecast pretty much a dead on average season, to July and August, where we forecast an above normal overall Atlantic hurricane season. And so, the numbers have gone up, but, we did maintain our numbers from July to August. And again, I do want to stress just how uncertain this outlook is. And if you're interested with each of our forecasts, we do put out numbers, but there's a really extensive document, 40 to 50 pages long, on our website that goes into a ton of detail describing kind of what we've seen so far and what we expect to see for the peak of the hurricane season. As Bill noted, I did have the great pleasure of studying under Dr. Bill Gray, and certainly, we wouldn't be doing seasonal forecasts at Colorado State if it were not for Dr. Gray. In addition to being the founder of the seasonal forecast and developing these predictions, he made just a tremendous amount of contributions to tropical cyclone intensity change, genesis, structure, just a giant in the field of hurricanes and tropical meteorology. And again, I was very fortunate to have had the opportunity to study with him for over 15 years, learned a tremendous amount from him, and we're trying to continue his legacy with the seasonal hurricane forecast. Again, this is actually our 40th year of doing seasonal hurricane predictions at Colorado State University. Just to give you an idea, our seasonal forecasts are based on historical data and historical weather and climate patterns. And so the way these got started in the early 1980s was Dr. Gray was kind of a fount of knowledge, basically Wikipedia before we had Wikipedia. And so he knew which years in the past were El Nino years, and he knew which years in the past were busy hurricane seasons in the Atlantic. And he noted in general, when you have El Nino, you tend to get fewer hurricanes in the Atlantic. And so this kind of gives you, the historical relationship and gives you kind of an empirical relationship. But the challenge is then discovering, why would something going on in the tropical Pacific Ocean impact hurricanes in the Atlantic Ocean thousands of miles away? And so here again, we see these composites. So in El Nino, you tend to have warmer water in the eastern and central tropical Pacific. So sea surface temperature anomalies or differences from average that are higher than normal. In La Nina, basically is the opposite of El Nino, colder than normal water in the eastern and central tropical Pacific. And then basically through research that he and others did, they found that the reason El Nino reduced storms in the Atlantic in general is that you tend to have higher levels of vertical wind shear, which is that change in wind direction and speed with height in the atmosphere. Too much vertical wind shear is detrimental for storm formation and intensification. So normally the winds at low levels in the Atlantic, so near the ocean surface, blow out of the east. Those are the trade winds. And at upper levels, they blow out of the west. In an El Nino year, you tend to get stronger winds out of the west at upper levels, maybe a little bit stronger trades. And so that overall increases your levels of vertical wind shear. Too much shear in the vertical tilts the hurricane circulation, disrupts it. You don't get the pressure fall that you need to get the winds to accelerate to reach hurricane strength. So overall, El Nino tends to knock down Atlantic storms, and especially your stronger storms. So the relationship with the number of storms is there, but it's stronger for hurricanes and even stronger for major hurricanes, because the stronger the storms, the more overall larger area of a conducive environment that you need. But now I want to dive back into 2023. Just a very brief reminder, again, we are forecasting an above normal hurricane season. So kind of give you kind of what's going on right now. Here are the current sea surface temperature anomalies or differences from average across the globe. And you can see the blue rectangle denotes the tropical Pacific Ocean. So you can see warm waters there. That's a big shift from the last 3 years where we had La Nina conditions basically persisting throughout the 2020, 2021, and 2022 hurricane seasons. However, you also see an extremely warm Atlantic at the same time. So that red rectangle denotes what's known as the Atlantic's main development region. And so as you would expect, the main development region is where most of the hurricanes that form in the Atlantic develop. And so we have effectively record warm waters there, but also a fairly robust El Nino event. Not the strongest on record, but it's getting up towards the moderate to potentially even strong threshold for the peak of the hurricane season. So we have these two kind of clash of the titans going on, and that's really where the big uncertainty lies with the 2023 season. If we had El Nino and the Atlantic was kind of near average water temperatures, we'd be forecasting an extremely quiet season. Alternatively, if we had, say, neutral conditions or even La Nina conditions in the tropical Pacific, given how warm the Atlantic is, we'd be forecasting a crazy busy hyperactive hurricane season. But El Nino is here. Hopefully some of you remember the late, great Chris Farley and as the wrestler El Nino back in, this was during the 1997 El Nino event. But we do have El Nino, and El Nino is likely to persist and probably get stronger over the next several months. So here, this blue rectangle denotes what's known as the Nino 3.4 region. And the Nino 3.4 region is the region that NOAA uses to monitor El Nino conditions. So when water temperatures in that box are 0.5 degree Celsius or more warmer than normal, NOAA will declare an El Nino event, provided those water temperatures persist and the other atmospheric circulation factors also point towards El Nino. And if the water temperatures in that box are 0.5 degree Celsius or more colder than normal, NOAA will declare a La Nina event. I think that's important to realize, is that you don't need huge temperature changes. Small temperature changes in the tropics make big differences in how the atmosphere then responds. And again, it's really critical how the atmosphere then responds for what drives overall what's going to happen with the Atlantic hurricane season. And, it's pretty much a slam dunk. We're going to have El Nino for the peak of the season, which is August through October. There is a large spread in the outcomes. And, whether you have a weak El Nino or a strong El Nino is a big difference. So normally, kind of colloquially, 0.5 degree Celsius to 1 degree Celsius is a weak El Nino. 1 to 1.5 degrees is a moderate El Nino. 1.5, anything exceeding 1.5 is a strong El Nino. So I would say at this point, it's a pretty good bet we're going to have a moderate to strong El Nino for the peak of the Atlantic hurricane season. But again, if it's 1 degree versus 2 degrees, that makes a big difference in the atmospheric circulation. And I think there's still quite a bit of uncertainty as to exactly how strong this El Nino is going to be. But obviously too, we are in August, so the El Nino can get stronger, but we don't have that much more time before the peak of the season. The peak of the season is only about a month away. The hurricane season peaks on September 10th. As you would expect, given how hot warm the Pacific is, rather, El Nino is pretty much a sure bet. NOAA has about a 95% chance of El Nino for the peak of the Atlantic hurricane season. And normally in an El Nino, this is a nice schematic that NOAA put together. This is basically the anomalous circulation that you get in an El Nino event. Since you have warmer water in the eastern and central tropical Pacific, that tends to shift where the thunderstorms form in the tropical Pacific. And so Dr. Gray used to always talk about an up and out circulation in the tropics where you have thunderstorms. And so at low levels, you have low level flow low level winds going into those thunderstorms. The air goes up in the thunderstorms and then spreads out at upper levels. So across the Caribbean and across the Atlantic in an El Nino, you get basically what we showed earlier: upper level westerly winds, lower level easterly winds that increase your vertical shear. You also tend to get a big old branch of subsiding air over the Atlantic, and where you have subsidence, you tend to have higher pressure and a more stable atmosphere. So this is kind of your cartoon of what normally happens in an El Nino year. So let's see kind of how that's tracking for 2023. So this is a plot showing the correlation since 1979 between the Nino 3.4 index, which again is an index that NOAA uses to monitor El Nino, and sea level pressure. And so when you have an El Nino, you tend to get warmer waters and lower pressure in the eastern and central tropical Pacific, and you get higher pressure over the Atlantic and the tropics. But in June and July of 2023, we actually had below normal pressures across the tropical Atlantic, and especially low in the subtropical Atlantic. And when you have these extremely low pressures in the subtropical Atlantic, what that tends to do is weaken your winds blowing across the Atlantic Ocean. The reason we have the trade winds is because canonically you have high pressure in the subtropics, low pressure in the tropics, and so the winds circulating around that high pressure basically are basically the trade winds. So that's the reason you have those trades. And so when you have a very low pressure in the subtropics, that weakens the trades. Weaker winds blowing across the ocean means less evaporation, which means less cooling, and tends to warm up the tropical Atlantic, which is what we've seen. The Atlantic always warms up from spring to summer, but it's warmed up a lot faster than normal in 2023. And so here again, we're looking at these vertical wind shear anomalies. And so over the Atlantic, this is looking at July 4th to August 2nd, which is the latest data that I had available from the European Center. And you look at the shear across the Atlantic, it's a bit high in the Western Caribbean, low farther east, a little bit high farther to the closer to Africa. But overall, you're not seeing a massive wall of shear that you normally see in an El Nino year. And so I put together a scatter plot. And so here's a plot showing the July anomaly in the tropical Pacific on the y-axis, so warmer waters in that region indicating El Nino. And on the x-axis, we have zonal wind shear. And so if we look historically, there's a pretty strong positive relationship. Anytime you get a correlation of 0.7 in weather or in climate, that's pretty good. So you see a pretty coherent relationship where warmer waters in the tropical Pacific drive higher shear. And then we see 2023, it's not really fitting real well on that little trend line. If you look at the other years where you've had water temperatures similar to 2023, we would expect shear of about 6-7 meters per second higher, about 10 to 12 knots. And so overall, this year is not behaving quite like your typical El Nino. And so that's one of the things these climate models were projecting, was that even though we had El Nino, we wouldn't necessarily see the wind shear response that we typically see. And this is through August 2nd. We could actually update this when the European Center reanalysis data comes out, which is about 5-6 days delayed. That shear is even going to go lower because the Caribbean's generally had low shear the last few days when they do their final analysis. So, 2023 from that perspective is not playing exactly like we would expect for an El Nino year, at least as of yet. And some of that, I think, is likely due to the fact that the Atlantic is so hot. And really, when we're talking about how the El Nino impacts the Atlantic, each of these, the global atmosphere ocean circulation functions as a single unit. So you can't just say we have El Nino, that's all we need to know, here's what's going to happen. Or the Atlantic's warm, here's what we need, that's all we need to know. It's how all these basins play together. And so when you have an El Nino, you have a warmer ocean and a warmer atmosphere in the tropical Pacific Ocean. And because of that warmth, you tend to have higher heights at upper levels in the atmosphere. On average, in the tropical Atlantic, in an El Nino, the water temperatures are near average, and so the heights there don't change that much. So at upper levels, you have higher heights in the Pacific, relatively low heights in the Atlantic, and that tends to help drive that westerly wind shear. Whereas this year, your heights are high everywhere because it's hot pretty much everywhere. And so overall, those gradients or differences aren't as strong. And so that's probably one of the reasons why we're not seeing as strong of shear in the Atlantic as you normally would expect for an El Nino. And again, the waters in the Atlantic right now are very, very warm, near record temperatures to record warm, depending on exactly where you look in the ocean basin. And so here's a plot showing correlations between sea surface temperatures in the Atlantic and accumulated cyclone energy, which is a geeky metric that accounts for storm frequency, intensity, and duration. So weak, short-lived storms like Arlene or Cindy this year generate very low levels of ACE. Long-lived major hurricanes like an Irma or Dorian generate tremendous levels of ACE. And so if you look at August sea surface temperatures correlated with seasonal levels of accumulated cyclone energy, and we toggle back and forth between what we currently observe and what's kind of the optimal correlation pattern for a busy hurricane season. You can see the match is pretty good. So again, if we didn't have the El Nino, we'd be going for an extremely busy season. So again, it kind of comes down to this clash of the titans. I do want to draw your attention that when we do these forecasts, we use a variety of different models. We use statistical models, which are based on historical data. We use statistical dynamical models, which use like the European Center, the UK Met Office, the Japan Meteorological Agency's models to forecast the large-scale environment. And then assuming those forecasts of the large-scale environment are correct, for the peak of the season, how would the Atlantic hurricane activity typically respond? With these forecasts, we do provide uncertainty bars. And so obviously we know, these numbers are our best estimate, but obviously there is uncertainty. And this year, again, there's even more uncertainty than would be from your normal historical errors. But this gives you an idea of kind of the uncertainty associated with these outlooks. The reason why we do the midpoint and emphasize the midpoint is because that gives kind of the general public your best estimate as to what's going to happen. If you provide a range, often what gets reported is the high end of the range. So if they say, if you forecast 7 to 11 hurricanes, the media will often jump and say, oh, it's up to 11 hurricanes, which the general public then views as 11 hurricanes, as opposed to what you're really forecasting, which is the midpoint is 9. But we do have uncertainties. And obviously, again, this year, the uncertainty is very, very high because we don't really have any great analogs. That's kind of the bread and butter of seasonal predictions or forecasting in general, right? Even if you're using dynamical models, it's always like, oh, we've seen this pattern before, and here's how things occurred when we had this pattern. we don't really have a great analog this year. 2023 is kind of out on its own. We've had really warm Atlantics before, but we haven't had those paired with a strong El Nino or a moderate to strong El Nino. And we've had moderate to strong El Ninos, but the Atlantic hasn't been nearly as warm as it is this year. So kind of how all this plays out really does remain to be seen. However, the next time we get this kind of setup, well, 2023 will be a great analog. So we'll just see how 2023 pans out. One index that we are forecasting this year that we haven't forecast before is accumulated cyclone energy, or ACE, west of 60 degrees west. And so I call this kind of angst ACE. And the reason is that that's kind of basically a longitude line that delineates about where the islands are in the Caribbean. So you're talking your Lesser Antilles, your Greater Antilles. And basically when you have ACE west of 60 degrees, that is where a lot of people live. And so basically when you have strong storms in that region, people are concerned. These storms are either going to make landfall or certainly cause quite a bit of concern. And so in general, this index actually correlates better also with landfalling storms in the North Atlantic, not just the United States, but also talking Canada, Mexico, Caribbean, Central America. And so in general, relatively speaking, in El Nino years, you get a little bit less ACE west of 60 degrees than you do in La Nina. And the reason why that's the case is likely due to the fact that in El Nino years, your subtropical high tends to be somewhat weaker. And because you have a weaker subtropical high, that tends to favor recurvature of hurricanes. So they're less likely to track west of 60, more likely just to stay out in the open Atlantic. So now I want to talk a little more about this hurricane season. And so it's been an interesting year. This is the third year in a row we've had a pretty decent gap where you haven't had storms during some point between mid-July and, say, mid-August. Last year was obviously especially remarkable because we went all the way from July 3rd to September 1st with no storms, the first time we had had that long of a period back since 1941. Prior to the show beginning, we were talking baseball. In 1941, that was the year that the splendid splinter, Ted Williams, hit 406. So it's been a long time. But this year, we did have storm. We did have dawn in July. But right now, it's fairly quiet. And so there is a lot of question as to, what's going on, The bell rings in not that long, and why aren't the storms there? And if you look at the Hurricane Center this morning, the tropical weather outlook that they just put out a couple hours ago, they're not anticipating any storm formations in the next few days. But we did actually have Brett and Cindy, so storms 3 and 4 on this track map, form in June. It was the first time on record we had 2 main development region storms during June. And that's typically when you have storm formations early in the season, it doesn't really correlate with what happens the rest of the season. But if they form in the deep tropics, such as Brett and Cindy did, that is typically a harbinger of a very busy overall Atlantic hurricane season. But again, since then we've had basically we had Dawn, which formed at higher latitudes. It almost hit for the hurricane cycle. It went through subtropical storm, subtropical depression, tropical depression, tropical storm, and hurricane. Just missed out on major hurricane, and it would have hit for the hurricane cycle. No storm on record has actually ever hit for the hurricane cycle. So we'll see if we can get one this year. But typically, if it's going to happen, it's going to have to be something at higher latitudes to hit all of those different phases. So far, though, we still are tracking a bit above normal. And again, that's because the Atlantic hurricane season is extremely peaked. It's very different from, say, the Western North Pacific or the Eastern North Pacific. The Atlantic season between August 20th and October 10th is about 90% of your season. It's very, very peaked. So it's really the next week or two where if these seasonal forecasts that are going for above normal are going to verify, things really do need to start heating up. Obviously, that's really what was a big surprise to us last year. The season ended up being kind of near normal overall, but again, it really didn't ramp up until September. Typically, you start to see stuff really ramp up in about a week or 10 days. So here's kind of where we are. This is a nice plot that from the National Hurricane Center showing your climatology, so where kind of how a normal season behaves, and you can see we're kind of in a little bit of a lull before the calm before the storm, so to speak, historically. And again, there's been busy seasons that had very little till September 1st and then really took off. There's been other seasons that were really busy early on and then died down. And so it kind of remains to be seen, obviously, how the 2023 hurricane season is going to play out. At this point, I think, nothing really would surprise me, really, in terms of how this season plays out. Maybe El Nino is really going to rear its head, and basically the hurricane season will not be nearly as busy as us and other groups are forecasting. Or maybe it'll be super hyperactive. It's really too early to know for sure at this point. But again, the bell does ring on August 20th. Dr. Gray used to actually ring a physical bell every year on August 20th, signaling the active part of the Atlantic hurricane season. And so we will be ringing the bell in his honor. I'm not on the 20th because that's on a weekend, but on August 19th, which is a weekday, we'll be ringing the bell in his honor, again, signifying the active climatological part of the Atlantic hurricane season. But, I spent some time yesterday, and I've spent a lot of time trying to figure out, why has the season kind of gotten quiet? And some of it's just climatologically, we had a lot of stuff early, and that's not normal. So this is actually more normal to not have all that much. But, the question is, why haven't we had the storms? And, it's not that we haven't had tropical disturbances, and there have actually been two systems that the Hurricane Center had a high chance of formation on that just never made it. Environment is critical, but there's internal structural characteristics as well that can determine whether a storm forms or not. And we look at the system in the Atlantic that actually didn't form in the Atlantic, but became Hurricane Dora, which is now cruising along throughout the central tropical Pacific, likely to cross the international dayline in a few days. That system, when the Hurricane Center started monitoring it, and you look at some of the environmental conditions, were extremely conducive for formation. Warm waters, low shear, high moisture, and yet no formation. And so the environmental conditions will load the dice, but also there are some internal characteristics, and we don't necessarily understand exactly how all that necessarily interplays with each other for Genesis. Genesis is a really challenging problem. But if I were to talk to you last year, or I did talk with you last year around this time, and there was a question, why is stuff not really taking off? I would have said a lot of it was, we had a lot of dry air, we had a lot of dust. This year, not the case. This is a plot showing dust aerosol optical depth, so basically the amount of dust in the Atlantic. And so here the black line is climatology, the blue line is 2023. It's been below average, and that's probably one of the reasons why the Atlantic is so warm right now, is we've had really weak winds, which have helped reduce evaporation, help warm up the Atlantic, but we also have had very little amounts of dust. And so dust is good at reflecting solar radiation back to space, and basically then you're not able to get as much warming, whereas if you don't have the dust, the sun can just beat down on the surface and cause additional warming. So I would say dust is not a big thing to blame for 2023 so far. The shear, again, we looked at this plot earlier. It might explain why we had stuff in the Western Caribbean, but these systems coming off Africa, in general, they've moved through an area of fairly low shear, and yet we haven't seen the storms. So overall vertical wind shear, again, blue is this year 2023, 2022 is climatology. You can see again, 2023 is in blue, climatology is in black. You can see again, kind of bouncing around a little high, a little low, but again, I wouldn't say there's any smoking gun thing with shear as well. And this is a nice plot. This is from the Cooperative Institute for Research in the Atmosphere, these last few plots. And this is kind of an amalgam of environmental parameters. And so black is climatology, blue is 2023. And these are formation probabilities in the tropical Atlantic. You can see, environmentally speaking, probabilities are really high. And they've generally been well above climatology, and yet we still haven't seen storms. And so overall, I would say the environment necessarily hasn't been super harsh. There's just internal structural characteristics, and you're kind of, all these parameters are averaging over a large region, and maybe it's just that, the overall environment is fairly conducive over a broad region, but where the systems happen to be, the environment is not as conducive. You'd have to go through each individual wave and look at what was driving the environment around each individual wave. And Genesis is a really challenging problem. And so again, environment loads the dice, but there's internal characteristics as well. But again, I was hoping through analysis the last few days to kind of give you an answer. It's this one quantity that's why we haven't seen stuff. But again, I would say there's no massive smoking gun answer here. The pressures have broadly been higher since about the 20th of July. And when you have higher pressures, that tends to be associated with more of the sinking motion. The models are forecasting these pressures to come back down. So I think the instability in the atmosphere is going to come back up, potentially leading to some higher potential for genesis here in the not too distant future. I like to look obviously at rainfall over Africa as well. So this is satellite derived, or I think this is satellite derived. This is basically rainfall estimates over West Africa or over Africa. And so here greens are above, oranges and yellows are below. Since early July, it's kind of a mixed bag. I generally look between about 10 to 15, 10 to 20 degrees north. As you can see, maybe a little below near average. I mean, I wouldn't say, again, there's a smoking gun factor here either, indicating why the season hasn't continued to be busy. But again, normally we don't see a lot in July, even through about this point in August. Again, the season doesn't really ramp up for about another week climatologically. Looking ahead, the Hurricane Center says nothing for the next week. I agree. Like, there doesn't look any massive smoking guns for the next week, but overall, in about 6 to 10 days, there is a pretty favorable low-level winds. So here, reds indicate low-level westerly winds, blues indicate low-level easterly wind anomalies. And so that area where these systems tend to come off Africa is going to be in an area of kind of horizontal spin. And so often when you get these kind of effectively like monsoon trough kind of setups, that tends to help spin up storms in the Atlantic. So you're still a few days out, but I would say maybe a week or a little bit beyond, you might start to see, potential for something developing in the Atlantic, east of the islands. So a lot of people look at these operational models and say, oh, the Canadian model had it this run, then it fell out the next. And so models, again, kind of really do struggle with genesis. And so what I like to look at a lot is these ensembles. And so this is this morning's ensemble outlook from the European Center for Medium Range Weather Forecast. It's ensemble prediction system, which uses 51 members. And you can see it's fairly busy. European Center, you have to be careful, has been too bullish the last few weeks, but there are signals in about a week or so, there are potentially of a couple of different waves developing off of the coast of Africa. Obviously, as you get further down in time, models will start to just kind of do their own thing. So I wouldn't necessarily take anything specific and say, we're going to see a storm potentially threatening one specific area, but just to give you an idea that there are potentials coming out, I would say in about a week to 10 days. There's a couple of wave candidates coming off Africa that look like they have at least some model support for genesis. This is a similar kind of output from the for the United States, the global ensemble forecast system. It's a little less bullish with these waves, so we'll see what happens. Obviously, if 2 weeks from now we're still looking at 5 named storms, 1 hurricane, and there's nothing on the horizon, then obviously we have to seriously be rethinking the forecast for this year. But again, I think there are some indications. I'd be surprised if we went through all of August with no named storms like we did last year. But you might be thinking that Klotzbach guy, CSU, they're out to lunch, so we want to look at somebody else. So I invite you to check out seasonalhurricanepredictions.org. It's a website that has, we have about, I think, 28 different groups contributing seasonal forecasts this year. These include government agencies, private sector weather companies, as well as universities. And the forecasts for 2023 really do kind of run the gamut. And this is one of the reasons why we've developed this website in the first place. So it was put together by our group at CSU with funding from AXA XL, and Barcelona Supercomputing Center really did they basically developed the website and did quite a bit of the work on getting this website up and running. So here are the forecasts. These are the number of hurricanes. So purples are private sector weather companies. Greens are government agencies. And greens are universities, and blues are government agencies. And you can see there's a huge spread this year. Had I shown you the same plot from last year or 2021, there wasn't nearly this kind of spread. And I think this really highlights the uncertainty associated with these outlooks. Some groups are forecasting a near to below normal season, 5-6 hurricanes. Others are extremely bullish with high ends of ranges going all the way up to like 14 hurricanes. And especially the dynamical models, the European Center and the UK Met Office have been very, very aggressive for the 2023 hurricane season. So again, there's a lot of spread. And just to highlight too, the red dot is the observed value to date. So we've had one hurricane, Don, and the average of all of the seasonal forecasts is 8 so far this year. And so with that, I will put up my contact information and I will try to answer any questions, keeping in mind that, this hurricane season, I'd say certainly is really keeping us humble. And, there's still a lot that we do not understand. And I feel like I've been in this business for over 20 years. And sometimes I feel like, I don't really know what the heck's going on. And so this year, I think is really just a real challenge because we're again, kind of in a space that we haven't been in historically. And so we have to kind of watch and wait and see, how the season's going to play out.
Very interesting. So much, Phil. I could come up with a quick question here. I was really intrigued by the shear problem. Is there a way to look at the contribution to the shear to see how much contribution the much lower than average easterly trades are to the lower shear values?
Yeah, I mean it's mostly still upper levels, just because your magnitude of the shear at low levels. I mean, you're talking maybe like a meter per second difference at low levels and like 3, 4, 5 meters per second at upper levels. So usually the big driver of the shear is your upper level winds. And that's what Bill Gray used to always look at. I mean, you look at the low level winds, but he always used to look at the upper level winds. And I think historically we focused a ton on upper level winds because we didn't really have the capability to be able to measure the differences, I think, in the low level winds as much because they were fairly small. With some of these better technology and better reanalysis data sets, we can kind of better measure these subtle differences in low level winds. But upper level winds, the gradients were strong enough where in El Nino you might have 10, 15 knots stronger upper level winds than in a La Nina. That you could measure with balloons and other stuff, even 20, 30 years, 40 years ago. So most of the contribution in general is coming from the upper level winds. But the level winds are not, if you get over short time periods, like a few days, certainly the low level winds can also be they can be at least half of the driver of the shear differences, depending on the situation.
Interesting. Been a while since we talked about the role of the rainy season in the tropical landmass of Africa. Could you refresh our memory as to how that plays out for the hurricane season?
Yeah, and so, we used to actually use rainfall over Africa as an explicit predictor in our statistical models. We don't use it anymore. I think there's been some measurement challenges over Africa, but in general, when West Africa, so the Sahel region, so just south of the Sahara Desert, is wetter than normal, that tends to be associated with effectively not necessarily more easterly waves, so these thunderstorm complexes, but more robust easterly waves. And if the waves are more robust, that they tend to basically just have a higher chance of forming and becoming tropical storms. I mean, there's certainly years where Africa's pretty wet and the Atlantic is near average, kind of like last year, Africa was really wet and Atlantic was near average. But in general, if you have a wet West Africa and the waves are more robust, it kind of loads the dice that they're more likely to become tropical storms. Although there's certainly been cases of waves that looked really healthy coming off Africa and just completely fell flat the second they hit the Atlantic if the shear is really strong or the waters are just too cold.
Okay. Yeah. So it's basically a contribution to the moisture content in the waves.
Yeah, just and also too, like so basically the low level spin in the waves, kind of how organized they are coming off Africa, because you will occasionally see systems coming off Africa that are like already rotating, like they come off Africa and they hit the ground running. I remember the first storm that I saw when I came to CSU in 2000, Alberto, basically it was like spinning over West Africa and it came off the coast and blew right up. Whereas there's others that kind of look marginal coming off Africa, and 24, 48 hours later they're off to the races. So it's not like that's the only thing that matters, but that is something that we also look at, because if Africa is really, really suppressed in terms of thunderstorms, in terms of precipitation, that tends to be associated with just overall quieter hurricane season.
Fascinating. Earlier, you said before we got on the air, you said you had some interesting thoughts on a link perhaps with Hurricane Dora and what's going on with El Nino. You want to fill us in?
Yeah, so Hurricane Dora, which actually was being monitored for formation in the Atlantic, that system didn't form in the Atlantic, but did form in the Pacific, and it's taken a pretty low latitude track. And so when you have storms take low latitude tracks in the Pacific Ocean, on the southern when you have counterclockwise circulation on the southern periphery of those systems, you have low level westerly winds. And if you look at the low level westerly winds near the equator, they've been fairly robust out of the west, even not even easterly, but actually out of the west. And so when you have westerly winds, that tends to reinforce El Nino because waters in the western tropical Pacific tend to be warmer than waters in the eastern tropical Pacific. Yeah, and here's a nice plot showing Dora's track. And so around the southern end of that circulation, you have low-level winds out of the west. So I think that westerly wind stress on the ocean is likely to potentially exacerbate or amplify the impacts of El Nino. So I think that's another wild card that, even when we did out the seasonal forecast August 3rd, we weren't, Dora was a potential system forming, but we didn't necessarily expect it to be a Category 4 hurricane for several days, tracking south of due west. So it's definitely been, you can see low-latitude tropical cyclones can amp up El Nino, and we saw that back in May where we had a low-latitude, a system that became, let me just remember the name of the system, the one in the western North Pacific. I used to be better at memorizing all this stuff. As I get older, these names kind of fade out. But Maywar, that system formed or was getting going at fairly low latitudes. A lot of low-level westerly winds from that kind of developing monsoonal system, and that I think really helped kind of take us from neutral and so to El Nino. So these systems can really amplify El Nino if they track at really low latitudes.
Well, it is interesting because it looks like the next one up in the Eastern Pacific, at least what little I looked at it, is also trending towards a straight westerly track at a fairly low latitude, depending on how big it develops.
Yeah, it is definitely, and that these systems tracking. So normally in an El Nino, you tend to see Eastern North Pacific storms tracking farther to the west, but they don't necessarily track south of due west. They just have a pretty strong subtropical ridge. And these systems this year, or Dora and potentially this next system, they're able to actually thrive because right now, normally in El Nino, you have warm waters in the tropical Pacific, but they also extend farther to the north. This year, we actually have kind of the opposite, where near Hawaii, the waters are actually really cold. And so if a storm were to track straight west towards Hawaii, normally the waters do get a little bit cooler, but there's a lot of shear, whereas a storm like Calvin, we saw when Calvin tracked towards Hawaii, the waters were just really cold. So it basically just couldn't really support deep convection. Whereas these storms tracking, if they track south of due west, the waters are a lot warmer. The shear over Dora is about 5 knots or less, and this has this nice annular circulation where it doesn't have a lot of like outer banding features, but those systems tend to be really robust and really kind of hold on. They're called annular storms. I prefer donuts because I like donuts and I think they look like donuts. But thankfully, in the case of Dora, it looks like it's not going to end up causing really any significant impacts in terms of the hurricane itself causing impacts to any land masses.
That's cool. I like that donut thing. Maybe we can come up with color scales and you can put your favorite flavor in there. Chocolate-covered donut flying across there.
Exactly.
This one looks like it's going to maintain hurricane strength all the way through the dateline. That's fairly unusual, isn't it?
Yeah. I think I need to look back and see, but I know Dora in 1999, same name, did something fairly similar. I'm not sure it was hurricane strength when I went across the dateline, but it did something fairly similar. So that's interesting because normally dateline crossers tend to be more of an El Nino thing, but 1999 was a pretty strong. It was actually the opposite, was La Nina. So these systems can do odd things even in other years. But yeah, it is interesting how the storm with the same name did something similar. It went across the dateline, although it looks like about the time Dora hits the dateline, it's going to get slammed by shear. So I suspect its traverse to the western North Pacific will be fairly short.
Yeah. Hal, why don't you jump in here? You look like you're thinking deeply.
Yeah, I am, Phil. A fantastic presentation. Phil, sometimes I hear people talk about more or less likeliness of hurricane activity based on the Madden-Julian oscillation. What is that, and how could that impact hurricane development in the Atlantic?
Yeah, so the Mount-Julian Oscillation is effectively equatorial thunderstorm activity that propagates around the globe about every 30 to 70 days. Sometimes it's pretty robust, sometimes it's not. Right now, it's really not, which is why I didn't really talk about it. So you have these things like El Nino that kind of will modulate seasonal hurricane activity, and then you have equatorial waves like the Mount-Julian Oscillation, Rossby waves, Kelvin waves that will modulate things on shorter timescales. And so this year, if you were to get a robust Mount-Julian Oscillation that basically were to enhance Atlantic storm activity or enhance thunderstorm activity, say over Africa in the Indian Ocean around September 5th, September 10th, we could see a huge flurry of activity. Whereas if for some reason it was actually in the Pacific Ocean and was enhancing storm activity there, that could really knock down your storm activity. Right now, there's not really any big indications that the MJO is going to be doing very much for the next couple of weeks, but that kind of remains to be seen. The models have been kind of all over the place, but right now it doesn't look like anything imminent in terms of the MJO. But yes, there are years where the MJO can be a big driver of kind of these subseasonal peaks. And so that's why at CSU, I didn't mention this, but we do 2-week forecasts as well as seasonal forecasts. Starting in early August, we do 2-week forecasts to try to kind of pinpoint when during the season we expect to see above or below normal periods. But the idea being that you can have a busy hurricane season that has a quiet period, like 2020, which seemed like storm a day or storm every other day. But late September 2020, the season got really quiet for about 10 days. And then it obviously really ramped back up. And there's other years like 2018, which, overall that's a head scratcher year, a weak El Nino, cold Atlantic, and yet still above normal. But early September, we had a really big flurry of activity that year. And that likely was modulated at least somewhat by a robust phase of the MJO coming through. So it can kind of be, it can either, I think that's some of the uncertainty bounds that we have with these seasonal forecasts is if you get a robust MJO that enhances storm activity at quote unquote the right time in the Atlantic, that can really bump up the Atlantic, maybe relative to what you would get if you had an MJO that say passed through now, and then you got the suppressed phase during the peak of the season. Right now though, we don't really see any big signs of an MJO, of a robust MJO coming through, but certainly that's something we'll be watching very closely, and we'll have more to say. Our next 2-week forecast will come out on August the 17th.
We'll be looking forward to that, Phil. You told us you needed to depart at 10:45. It is that witching hour now, so I know you're busy and doing these kind of talks with throughout this time of the season. Thank you so much for spending time with us.
Yeah, thanks so much. Take care, everyone.
Thanks, Phil. We appreciate it. And we had a lot of questions coming in online. Wish you had time to get to all of them, but thank you for your time today, Phil. We appreciate it. And thanks for the good insight, Bill and Hal, on the questions. So thanks, Phil. Good luck in the next presentation. Time to regroup and hit start again.
Thank you. Take care. Bye-bye.
As always, we're going to keep going here. We've got more to do here now that Phil's gone. We're going to talk about a number of really cool things. So don't go away, but we want to thank our sponsors. We're part of the program once again, USAA. USAA has been a sponsor of the National Tropical Weather Conference from the very beginning, as well as a lot of the other programs done by the Storm Science Network. So we appreciate USAA. Thank you so much. The South Padre Island Convention and Visitors Bureau, that's where the National Tropical Weather Conference is held every year. And we'll be back there at the Courtyard by Marriott in April of 2024. Hope you can join us in person and come meet all these folks we have on the program week in and week out. The Weather Company, proud sponsor of the event, and Weatherboy. So thanks to all of those organizations and groups that make this event a possibility. All right, let's get a hurricane seasonal update from Bill. After that, we're going to get a GeoTrek update, and then we're going to learn about the hurricane tours in the Galveston area. I got to do that last year, and it's fascinating. Bill?
Great. Okay. Well, I've already had Phil talk a little bit about the long-lived Dora, and he added a feature I had forgotten about, that it was from a system that originally attracted attention out in the Atlantic. As for the Atlantic, what we're looking at this morning is basically a few clusters of thunderstorms, one north of heading towards the Bahamas, another that's in the Eastern Caribbean. There was some nocturnal convection over here south of Cuba, but none of these disturbances are exciting the attention of any of the models, nor of the Hurricane Center. And we're looking at this, for those of us that live near the water, our most favorite forecast for the outlook during the season. In the Eastern Pacific, there's a couple of areas. This one is not expected to develop much well out to the east here, but the one that just came off of Central America and southern Mexico, a large area of thunderstorms. I can detect what looks like a little bit of circulation, at least in the mid-levels, going on here. And it is being outlooked. They expect a 60% chance of it developing probably this weekend or early next week. So we'll keep an eye on that. And there is the picture that shows Dora in its current state is just as vibrant as it was several days ago. So it's racking up a lot of Eastern Pacific ACE as it heads westward. And the date line's over here. It only needs a couple more days and it'll have reached the date line. That and we already saw those, so I'm going to stop it there and turn it over to Hal to give us a nice update on GeoTrek and then the great hurricane tours he does for the city of Galveston.
Yeah, that's great, Bill. Thanks for the tropical update there. Wow, what a great broadcast here to get to hear Phil give a presentation and interact with him and ask him any questions. Well, y'all, with GeoTrek, we're traveling the world finding stories related to extreme weather and natural disasters not covered by the mainstream media. We're trying to understand the physical processes behind these extremes, their impact on society, and what we can do to get out ahead of them to reduce the losses. Y'all, we're moving into hurricane season. I wanted to thank everyone for making us the #1 podcast on the topic of natural disasters, according to FeedSpot. Last year, we did a lot of podcasts related to hurricane preparedness and hurricane education. And you can find a lot of those on our website, just wherever you listen to podcasts, whether it's Apple Podcasts, Spotify, wherever you listen, check out GeoTrek podcast. Last year, we did a 2-part series in August that was with Chris Franklin, the chief meteorologist with WWL-TV. He's a New Orleans native. He's worked there in New Orleans for a long time. And we did a 2-part podcast, episodes number 42 and 43, called Remembering Hurricane Katrina with Chris Franklin. Check those out, y'all. Katrina has so many lessons that we can learn from it, all the way from preparedness to forecasting to impact. Really interesting to hear Chris Franklin's perspective on that. Again, he was a new meteorologist right out of meteorology school with a new degree, and there he was working in New Orleans when Katrina approached. Really interesting to hear his perspective on what the storm impacts were, his play-by-play through the storm, and then long-term hearing about the assessment of the region for risk from future hurricanes. So again, that's a 2-part podcast, episodes 42 and 43. We aired them last summer. We're anticipating a lot of episodes this year as well related to hurricanes. I like to get on the ground in hurricane disaster zones. So a lot of the content's really fresh, really raw. The ones I recorded with Chris Franklin were recorded remotely before hurricane season really ramped up last year, but you can check those out wherever you listen to podcasts. Well, I'm going to share my screen here, and I'm going to share a little bit about Galveston Hurricane Tour. This is a really educational thing that I developed right before Hurricane Harvey hit in 2017. And let me share a little bit with you right here about the hurricane tour. I'll start by actually looking at the tour types. So this is a tour in Galveston, Texas, the site of the deadliest disaster in U.S. history. And this started again in 2017. I've been doing them for 6 years. And now really the most popular tour we have is a walking tour, generally on Saturday nights, but we can customize it for a group. But we go downtown. We look at some areas that have had huge impacts, not only from the 1900 storm, but also storms like Hurricane Carla, Hurricane Ike. And this is a big impact of the hurricanes we've had here onto historic preservation as well. So we go into historic neighborhoods. This neighborhood with this picture here, you can see a tree sculpture in the foreground. Every one of these houses in the background has a high watermark from Hurricane Ike. So we really talk about the impacts of hurricanes on historic preservation. We go downtown, Galveston, we have high watermarks for at least 5 hurricanes, and we really preserve this history. That's something we talk a lot about. We not only look at the local history, but we look at some of these educational lessons that we can apply beyond Galveston as well. We have bus groups and school groups that have sometimes come. So you can come with your group. Last year, I think I did 4 school tours, especially in the springtime. So especially, I'd say Houston Metro, there are tons of schools that maybe do a curriculum on natural disasters or meteorology. A lot of times they'll come down to the island. I'll meet them for an extended lunch and show them around. It's great I get a lot of 5th through 7th, 8th graders that come in the tour. And it's just great to spend a few hours with them. And also university students. I've had universities come, especially during spring break, from northern states, in part to thaw out, in part to learn about the coastal environment. Sometimes you'll meet students that have never been to the beach before, let alone the place like Galveston Island, where we've had so many impacts over the years. So just really cool opportunity to come down with a group. Before we close out here, I'll just give you a few snapshots here of what the walking tour looks like. And again, we're covering not only the local history of the deadliest natural disaster in U.S. history, but also just a lot of innovations that happened here. Here in Galveston, you can go to the Federal Building, where there used to be a radar dome, and Dan Rather was there during Hurricane Carla, and that was the first televised broadcast of a landfalling hurricane in Hurricane Carla back in 1961. So we cover that history of innovations that have happened here. We talk about the impact of storm surges. This is a photograph after the 1900 storm. Again, people often think of hurricanes as wind events, but it's really the water that produces the most destruction and kills the most people. And so we look at, pictures of the 1900 storm and previous hurricanes here. But unfortunately, that's not just something from the distant past. I also have pictures here from Hurricane Michael in 2018. We see the impacts of storm surges even to this day. Along the Gulf Coast. These are photographs. I have a lot of photographs from Galveston in 1900. And we do talk a bit about the death and destruction. You see the smoke there from fires where they were burning the bodies after the 1900 storm. Galveston really responded in a fiercely resilient way after the 1900 storm, building one of the world's longest seawalls. And check this out, constructing 4 ocean-going ships in Europe, building a canal, digging a canal through Galveston City, and then basically floating these ships called dredge hoppers across the Atlantic. They dredged up sediment from Galveston Bay over a 6-year period, and then piped that sediment into the city, raising an inhabited city as high as 17 feet. Tremendous amount of resiliency that happened here to preserve the city and protect it from the future. We talk about all of that in the tour. We definitely talk about the grade raising. Again, I have hundreds of photos, no time to really go through all of them right now. We do talk about evacuation and shelter in place. This place, Ursuline Academy, there's a plaque out in front of where it used to be located, where it talks about the 1,500 people that were saved by the Ursuline nuns. This was a cathedral and a basically Catholic academy that withstood and barely survived the 1900 storm. 1,500 lives were saved inside there during 1900. And then in 1961, unfortunately, the convent and the cathedral were taken out by Hurricane Carla tornado in 1961. So, a lot of history here. Again, I think that I'll leave us with that and stop sharing my screen, but check out the tour. You can go to GalvestonHurricaneTour.com. Again, we get into the history here, the impacts, but it's well beyond death and destruction. We talk a lot about how to make yourself more resilient. We talk about a lot of these innovations that have happened here too, and how that can apply to your hurricane-prone community wherever you live. Thanks, Tim and Alex. I'm sorry, Tim, go ahead.
I was going to say, so much of it is about the timing. We had the opportunity to do the tour during Oktoberfest, so that made it especially fun. But I love the stories as you're going down the streets and you stop and you stop at one location and talk about these buildings and the things that happened there, and you try to put the people back into time like that, like you were there.
Yeah, and it's so much human interest, these survival stories, people that overcame unbelievable odds, like Daisy Thorne. She lived in an apartment complex with 64 units. 63 of them were annihilated by the 1900 storm. She and her family were huddling in the only unit that survived. So we talk about these human interest stories. And Tim, like you said, we try to align it with fun social events. We're doing a tour this year again during Galveston during Galveston Oktoberfest in late October. And the anniversary of the 1900 storm is on a Friday this year. There's going to be a community event that's on Friday, September 8th, anniversary of the deadliest disaster in U.S. history. Right here in Galveston, we're going to do a special event that evening. So if people want to come, we're often trying to tie it in with social events here on the island.
How long is the walk? I remember it, but I don't know how long it is. It's not particularly long. It's more, just in the downtown area.
Tim, thanks for asking. The walk is 2 miles, but the tour now runs about 3.5 hours because we stop for gumbo and food in the middle. So we have we've built in a dinner stop, and at first it was optional, and everyone always wants to do it. We go to Little Daddy's Gumbo Bar, and they have great seafood and not seafood, salads, gumbo, everything. So we basically walk for about an hour and a half take a 1 hour dinner break, and then continue for about 45 minutes. So typically Saturday night, we do that walking tour, just a 2-mile walk, but takes us over 3 hours because we stop a lot and then we stop for dinner.
It's not so much exercise as it is learning.
Yeah, a lot of education. And I want to say one last thing. You'll hear a lot of stories from me, but I'm amazed by how many people come on the tour that said, oh, I remember Hurricane Carla, or my parents told me about Hurricane Alicia. And so a lot of the visitors have stories themselves, survival stories from themselves or their family. So it's designed to be very interactive. You'll learn from me, but also other visitors on the tour.
You're still learning every time you do a tour, probably.
Sometimes I feel like I learn more from the visitors than they learn from me, because someone just told me about their grandparent or great grandparents that survived the 1900 storm. So we're still hearing fresh stories. It's pretty fascinating.
Terrific. Well, look forward to doing it again sometime, because it really is a great tour. So Hal, thank you for that, and good luck with it. And tell them again the website. People want to check it out.
Yeah, it's GalvestonHurricaneTour.com. And I feel it aligns. I know, Tim, what you and Alex and Bill have done, really emphasizing education, not just for adults, but, this year at NTWC in South Padre, we had the high school students. And, you guys are always trying to reach out and engage and educate as many people as possible. That's kind of what we're trying to do up here on the ground with the Hurricane Tour. So just go to GalvestonHurricaneTour.com. Come on down to the island. Love to show you around. I'm
in for the gumbo and Oktoberfest. I'm in. Thanks, Hal. We appreciate it. Bill, any final thoughts today before we wrap this up? It was a great program again today.
Yeah, this year marks the 40th anniversary of the landfall of Hurricane Alicia next week.
Oh, wow.
The date. So that's there. We're 15 years past Ike. It's hard to believe.
I remember in Hurricane Alicia sitting by the door of our newsroom with the door open so we could listen to KTRH on the radio and listen to Wayne Dolcefino and all those guys, because we backed the car up to the door so you could pick up Houston Radio. It's 300 miles away, but we could pick it up and listen to the landfall of Alicia. That was one of my first summers in Texas, and that was an introduction to hurricanes here. Quite an event.
Bill, they're obsessed with these Houston Hurricanes down there in South Texas because they don't get hurricanes down there anymore.
I like the way you think.
I shouldn't say that. We just recently had people talk about 1933 and 1967. So, eventually it comes knocking on your door, right?
This is true.
They're like those golf announcers, Hal. They say he never 3-putts, and the poor guy 3-putts the very next time up. So, Tim, tell everybody you're going to get a hurricane now because Hal mentioned it.
Yeah, exactly. It's coming. It's coming. Just plan on it. Guys, thanks. Great program today. Really insightful stuff. We appreciate it. It's 11 o'clock, so it's time to wrap up. Thanks to everybody who joined us online. We appreciate that. Some good questions came in. Sorry we didn't get to all of them today. Dr. Phil had to take off a little bit early, but he's already into his next presentation. So thank you, Dr. Phil, for being here today. Hal and Bill, great job as always. Appreciate the insight, the insightful questions. Thanks to our sponsors who make this event possible each and every week: USAA, the South Padre Island Convention and Visitors Bureau, the Weather Company, and Weather Boy. Those are the folks who assure that we can be here spreading the news with you and showing you what's going on, the latest in technology and the latest in tropical weather here in the Atlantic Basin. All right, that's it, guys. Thanks. Next week, it's George Siegel from Last House Standing and Alan Strum, meteorologist with WEAR in Pensacola, Florida. They'll be with us next Wednesday, so we hope to see you at 10 o'clock next Wednesday morning. Until then, have a great week.
We hope you enjoyed this episode of NTWC Live Hurricane Center Podcast. If you did, head over to Apple Podcasts and leave us a 5-star review. And join us next week. This is NTWC Live.